So today we're going to talk about graphing inequalities on a number line. So the last few days we've been looking at just solving them. We had a basic example of like this. We would have x minus 2 is less than 4. And we knew that we were looking for a solution that was, well, we know x is less than 6. And so we know that is all of the possible solutions. And we can go on forever and ever picking numbers that we can plug in and get a solution that will work. And so how do we show that on a graph? That's what we're going to take a look at. So ignoring this problem, here's where we're going to start. We're going to look at 5 is less than x. And what I want to do is I want to graph it on this number line to kind of see where are all of these solutions located on the number line. As you can see, I've got my number line marked, and make sure when you do a number line that you mark each tick by the same measure. So you can count by ones, you can count by twos, so on and so forth. Just make sure you're counting by a consistent amount every single time. So before I start going into the conventional circles and arrows and all that stuff, I just want to look at this number line and pick what are some numbers that work. Well, looking at this number line, I know automatically that 6 is bigger than 5. That's something hopefully you learned in kindergarten. 6 is bigger than 5. Well, I also know that 7 is bigger than 5, and I also know that 8 is bigger than 5. And I can keep going on and on and on forever. Well, what about over here? I know that 5 is definitely not a solution. I can't say 5 is less than 5. That is definitely not true, because number isn't less than itself. Now, if I had less than or equal to, this would work, but we don't. So to illustrate that 5 doesn't work, I put an open circle here. Now you could be wondering, well, Mr. Heading, why would we put an open circle there? There's no numbers in between 5 and 6. That is where you are wrong. What about 5.5? Does that work for my inequality? Well, let's see, if I put 5 less than 5.5. That is actually a true statement. And well, I could keep doing this over and over. I could pick 5.2, I can pick 5.1. I could even say that 5 is less than 5.00001. Even though it's 0.00001, it's still bigger. So we draw this arrow to represent all these numbers, not just the whole numbers, but all the decimals that fit in between. So we just saw a basic example of graphing an inequality. You could be wondering, well, how do I know which way to make the arrow? How do I make the circles? So on and so forth. So I've come up with this little method, or this way, to help us remember what we're doing. So first of all, we have a less than and greater than sign. In this case, when we're talking about graphing, these two have the same thing. They both are an open circle, meaning that the number that we are graphing is not a solution. So for example, in our last one, we had 5 is less than x, or sorry, let's see, that was, 5 less than x. So 5 was not a solution, so we use an open circle. Now, these two, less than or equal to and greater than or equal to, well, these are closed circles. So for example, if I had 5 is less than or equal to x, 5 would be a solution. I could write down 5 is less than or equal to 5, and no one would look at me like I'm crazy. Well, maybe if it's one of my students. So we know these two give us open, these two give us closed. Now, looking at this inequality, how do I know which way to make the arrow? So let's see. Let's start with determining whether it's going to be an open or closed. So I see right here that I have the equal to sign. So I know I'm going to make a closed circle at 13. So let me go ahead and do that. Where's my closed circle at 13? Well, then we have to figure out, well, which direction on my number line are all of the numbers that are less than or equal to 13. Well, I know you probably know this already just by looking at it, but let's pick a test blank. Well, let's see, 12. Is 12 a possible number? So I put in 12, 12 less than or equal to 13, and yes, that works. So since 12 works, then I can assume 11 works, and 10 works, and so on and so forth. So my arrow is going to go this way. Now, if I were to pick 14, for example, instead of 12, well, we know if I plug in 14, I'll get 14 is less than or equal to 13. Well, we know that is definitely not the case. So what we do, we determine whether it's going to be an open circle or a closed circle. Then we draw our arrow. Pick a number. Does it work? If so, draw your arrow that way. If it doesn't work, like for example with 14, draw the opposite way. So here's what I want you to do. I want you to take 2 minutes. Here are 2 problems. I want you to fill out the number line. So make sure you mark it, make sure you count them evenly, and then graph these 2 inequalities. Determine whether it's going to be an open circle or a closed circle, and then which way your arrow is going to go. So I'm going to give you about 2 minutes to give this a go. So hopefully you had enough time to go ahead and complete the problem. So I'm going to go ahead and do this with you. Normally I'd have you come to the board, but well, it's a video right now, so can't really write on it. So first thing we're going to do is we're going to label our number line. And what I tend to do is I like to start out with putting the middle number right here, and then working my way out. So -5, -6, -7, -3, -2, -1. And one thing to remember when you're labeling a negative number line is that even though it looks weird, -3 is actually bigger than -4, and so on and so forth. So make sure your number line is labeled correctly. Well, first step, I'm going to check and see, is this an open or closed circle? Well, I'm missing my equal bar, so I know it's going to be an open circle. Then I have to go ahead and determine which way is my arrow going to be. So let's see, I want to go ahead and pick a point, and I'm going to pick -5. So I'm going to plug that into my inequality. So I have -4 is greater than -5. Well, is -4 greater than 5? Hopefully you're shaking your head yes, because that's the case. So since this is true, I'm going to go ahead and draw my arrow going to the left. Now let's do the other problem. So again, I'm going to start by labeling my number lines, 11, 12, 13, 14, working our way backwards. So, and these are the easy number lines to make. Then again, first thing I'm going to look at, is it going to be an open or a closed circle? So this one, well, it's going to be a closed because I have the equals bar. So I'm going to draw my closed circle. Then I'm going to pick a point. So I'm going to pick a point, and hopefully you know this is wrong. I take 10. So I'm going to put 10 is greater than or equal to 11. Well, 10 is definitely not greater than or equal to 11. Since that doesn't work, I know my arrow is going to go the opposite direction. So that's how we graph these two inequalities on a number line. So let's take a look at a problem, a situation. So what inequality describes the situation below? And be sure to define a variable. So again, part of this of math is we want to be able to use what we're talking about. Yes, I understand this is kind of a fictitious situation, but you'll understand the point, hopefully. So here's the situation. We're looking to go ride some horses, to go on trail rides. And, well, it starts at $19.99. Okay, so since I'm talking about a trail ride, I'm going to define T. T is the amount we pay, money per trail ride or something like that, how much we're going to pay for each trail ride. So I want to write an inequality that fits this situation. Well, let's see. I know T is going to be involved somewhere, and I know that $19.99 is going to be involved there too. So the question is, what is the inequality sign going to be? Well, looking at the problem, it says starting at $19.99, meaning that the prices are going to go up. This is the bare minimum amount I'm going to spend on my trail ride. So to show that it's going to be more than $19.99, it can be, I'm going to have greater than or equal to. We could pay $19.99 or we could pay $25, $30, depends on how far we go on our horses. So that's how we write an inequality to fit this situation. Now, for tonight's homework, what you're going to do is you're going to see something a little different. You're going to have this, 3x minus 4 is less than 5, for example. And we'll just say this is an example. This isn't a problem that's actually on your homework. But what you're going to have to do is it's going to say solve and graph. So you're going to have to apply what you did yesterday and the day before and using our 5 steps, a distributive property, combining like terms on the same side, moving variable terms to the same side, undoing addition, subtraction, undoing multiplication, division, and then graph once you have finished. So use what you've done before to solve this and then graph them like we've done today.